So yesterday we worked on when you're given a slope and a y or a slope and a point, can you actually develop the equation without graphing? And you were using the point slope form. So take a minute and rattle off that point slope form. Tell me what it is. Write it down. What is that formula? If you wrote y minus y1 is equal to m times x minus x1, you're right. And there were a couple of things we had to pay attention to. One was negatives. We had to put in parentheses, and we had to really make sure and rewrite when we were with those double negatives. So today, we're actually not going to be given the slope. Okay, we're not going to be given the slope. I'm actually going to give you 2 points, and we're going to have to figure it out from there. So let's take a look at this problem. So I have these 2 points, and they wants us to find the equation. So it's giving me negative 3, 4. So 1, 2, 3, 1, 2, 3, 4. And negative 6, 2. So 1, 2, 3, 4, 5, 6, 1, 2. And it wants me to find the equation between those 2 points. So if I go ahead and draw a line between these 2 points, you can see that I think my line is crossing here at negative 1. But that may not be exact. Okay, that may not be exact. My graph is just an estimate. So it's pretty difficult to come up with an accurate B if I'm hand graphing. Okay, and I know that I need to have my slope, and I know I can find my slope either using my graph here. I can definitely come up with my slope by just using my slope triangle. But what is the other way to find slope? If you're saying use the formula, you are correct. Okay, I can definitely use y2 minus y1, x2 minus x1, and that would give me my slope. Okay, so point slope form allows us to not have to graph at all. Okay, we're not going to graph at all, but we know that we have to have all those pieces. Okay, so we have to have y minus y1, our slope, and x minus x1. So when we are given 2 points, okay, we're given the 2 points, we're actually going to calculate slope first. So remember that slope formula that we just talked about, y2 minus y1, x2 minus x1, and when we solved those, we used parentheses to help us not lose anything. And we have x1, y1, x2, y2, and labeling was really important. So let's go ahead and find our slope. Okay, so y2 is 2. The matching number is the 4. Then I have the negative 6 and a negative 3. So on top, 2 minus 4, that gives me a negative 2. Negative 6, negative, negative, that becomes a positive. That is a negative 3. So if I simplify that, my slope is going to be 2/3. So now I have my slope. Okay, now I have my slope. Now it wants me to pick x1, y1. Okay, x1, y1. And we know that this one is x1, y1. And in actuality, it doesn't make any difference which point you pick. But since it asks for x1, y1, I'm going to go ahead and use x1, y1. So y minus, let's make our template here. And I'm going to put in those extra parentheses to help me. And let's drop our numbers in. So I know that my slope is 2/3. So that is here. Well, x1 is negative 3. So that is going to go there. And then I have a 4. So now remember that double negatives and rewriting. So this side is fine. My slope is fine, but there's a double negative. So x plus 3. And now we're just going to solve for y. So y minus 4 equals 2/3 x plus. So remember, 2/3 times 3/1, that's 6/3, which is going to give me 2. Moving my 4, y is equal to 2/3 x plus 6. So that is slope-intercept form. Y equals 2/3 x plus 6. Now it wants standard form. So let's go ahead and clear our fractions. So let's multiply everything by 3. So 3y is equal to 2x plus 18. Moving my 2x, I have negative 2x plus 3y equals 18. And then remembering that a needs to be positive, multiply that by a negative 1. 2x minus 3y is equal to a negative 18. And that is my best answer for standard form. So in actuality, the only new step is this one. Okay, that's the only new step. I have to calculate slope. I don't have slope. So I need to make use of the slope formula and go ahead and calculate it. All right, so let's go ahead and hit pause. And I want you to work through this problem. I want you to find your slope, put it into point slope, solve to y, and then take it to standard form. Let's see what you come up with. All right, let's see how you did. So calculating slope. 6 and 0, negative 4 and 5. So I have 6 and negative 9, and that simplifies. Remember, slope always simplifies down. Do not leave it as big numbers. Always check to make sure that that is simplified to negative 2/3. Now, just because I can, and I want to show you that it doesn't make any difference, instead of using the x1, y1, I'm going to use x2, y2 because it's the same process, okay? I just need 1 point. So y minus, and if you used the other one, that's fine. I just want to show you that I'm going to get exactly the same answer you got. All right. So y minus, there's a 6. Here's my negative 2/3. And then I have a negative 4. So rewriting y minus 6, negative 2/3 x, negative negative. Oops, let me go ahead and put my parenthesis there. That's a positive. Now, distributing negative 2/3 times 4. Okay, now this is going to be a decimal, and that's okay. That's negative 8 over 3. Okay, negative 8 over 3. And I know that my b needs to be a decimal so that I can actually graph it. So when we distribute here, so negative 2/3 x, we're going to change that negative 2/3 to negative 2 point, or that negative 8/3 to negative 2.7. Okay, negative 2.7. And we're going to come back. We're going to come back to our equation. So I am actually going to write out the equation. Y minus 6 equals 2/3 x minus 8/3, because we're going to need that to get to standard form. Okay? All right, let's keep going. Adding my 6. So y equals negative 2/3 x plus, and if I have 6, and I'm adding that to negative 2.7, I come up with a positive 3.3. Now that's fine for slope-intercept form, okay? So y equals negative 2/3 x plus 3.3. It is totally acceptable for this to be a decimal. But what is not acceptable is to have decimals or fractions in standard form, okay? So it is not useful for me to be here because that is rounding. So I need to go back to this step, okay, right here. Go back to where I distributed the 2/3, okay, where I distributed the 2/3, and I need to make use of those fractions instead, because I don't want to lose the accuracy of my equation. So if I have too much rounding there, then it really impacts things, because this would be $2.70. Well, that bill was actually 2.67. That's 3 cents if you think about the rounding. So when I look at this and I'm going to take it to standard form, I need to multiply by 3 4 times. So I have 3y minus 18. Remember, these two are going to go away. So I have a negative 2x, and then the 3 is going to go away, and there's a negative 8. So notice now I have absolutely no fractions. And I have two things to move. I need to move the 2x, the negative 2x, which is going to make it positive. And I need to move the negative 18, which makes it positive. So I have 2x plus 3y equals 10. Okay? 2x plus 3y. That is my standard form. All right, so be very cautious when you come up with decimals on your B that you're going to have to go backwards a step where you actually had the division and the fraction there, and that is where you want to clear fractions to change to standard form. All right, you should be good to go today. Work on those point slope forms and slope and solving to standard form. I know that you're going to do great on this, and I will catch you on the next slide where we're going to be talking, next video, and we're going to be talking about what happens with parallel and perpendicular slopes.